All right, so we are going to start, finally, math for business or business math. And in 3.1, we're going to figure out what functions are. And we're going to define them, we're going to evaluate them, we're going to find the domain, and then we're going to utilize the difference quotient. So first of all, a function is going to be defined as an equation where every x only generates a single y value. A single y value. So I can look at that by, for instance, if I want to see a few points. So let's say I've got 0, 2. Let's say I've got 3, 5. Let's say I've got 0, 7, and 4, 9. Okay, so this is 4 points that I can plot, where the x coordinate is 0, the y coordinate is 2, x is 3, y is 5, and blah, blah, blah. All right, so the question is, can every x value only generate a single y value? So over here, I have a 0, and he generates a 2. Okay, so I have a 0 that will generate a 2. Over here, I have a 3 that generates a 5. Here, I just entered danger world because I have a 0 that also generates a 7. Okay, so I have a 0 that generates a 2 and a 0 that generates a 7. So a single x of 0 generated 2 y values. Okay, and then the final one is I got a 4 that generates a 9. Okay, so this is an issue. This means that he's still a relation. In other words, there's a relationship between my x's and y's. But when I step back and really look at it, I can't further define it. I cannot say, yes, you are a function, because you failed. Okay, this single x made 2 y's, and I'm not allowed to do that. Okay, so that's one way to look at it. Another way to look at it is make sure that your y in your equation only has an exponent of 1. Okay, an exponent of 1. So for instance, if I have y equals x to the third minus 17, what's the exponent on your y? It's a 1 that I'm too lazy to write. So this right now is a function. Okay, if I have something like x squared plus y squared is 9, I can tell you right now this is not a function. Why isn't he a function? Because my y has an exponent that's not 1. Okay, so he is not a function. So now we know kind of sort of how to define them. Then we want to evaluate. So when we evaluate a function, what we're going to do is substitute in your x value to figure out your y value. Okay, to figure out your y value. Okay, so let's go back down to this one. Now that I've stated that he is a function, instead of saying y equals, I'm going to change my notation. And I'm now going to say I am a function, so I'm going to say f. The variables I have chosen to play with are x's. So this says a function of x. And it now says x to the third minus 17. I can only trash the y and replace it with f of x after I've determined if he's a function or not. So I cannot change this to f of x. Why? Because this is not a function. Okay, so now what if I want to evaluate? I could say, well, what's f of 2? So wherever there's an x, instead of putting an x, what am I going to put? I'm going to put a 2. I could say f of cat. Okay, so f of cat means wherever there's an x, guess what you're going to put? you're going to put a cat. Okay, so on this one, if I shove in a 2, that gives me 2 to the third minus 17. Well, what is 2 times 2 times 2? That's 8. So I'll have 8 minus 17, which is going to be negative 9. Okay, what did you just find out? You just figured out if you evaluate it 2, you get negative 9 for an answer, which means that point is on this graph. Okay, you just found the point. The domain is going to be everything or all x's that you are allowed to use. And we're going to use something called interval notation to decide what that is. Okay, so look back down here. If I asked you for the domain of these 4 points, you would say your domain is 0, 3, and 4. Because those are the x's that you're allowed to use. So what about down here? Is there any x that I can't use? Is there any x that's off limits? So one of the things that I look for is going to be, I'm trying to write this all on one page, okay? So danger zones, okay? Basically, I'm going to say that I can use every x out there except for if I have a variable in my denominator. That means I got to watch out. Or if I have an even root, which is like a square root. Okay, so if I have something like x plus 4, there's a little 2 that's sitting there that I'm too lazy to write. So this 2 is even, and this is a root. Okay, a variable in a denominator would be something like x plus 3 over x squared minus 16. I got a variable in my denominator, so I better watch it. There's probably something that's going to mess me up. So unless I see one of these two things for now, I'm going to assume that my domain, or the x values I'm allowed to use, is going to be all the numbers out there. Or I'll say all real numbers. Okay? So that's what I'm going to assume, and then in the next video we're going to do some practice. We need to probably hit interval notation really quick. So you learned interval notation way back when. You learned that, like, I could write this as x is greater than 3. This represents an infinite number of numbers because anything that's bigger than 3 works. Okay, 4 is bigger than 3, so 4 is an answer. A million is bigger than 3, so a million is an answer. There's an infinite number of answers for this. So back when we used inequalities, which is the greater than, less than, greater than or equal to, less than or equal to. So greater than, less than, greater than or equal to, and then less than or equal to. Your brain could not comprehend interval notation. So we use this until your brains developed enough to where we could use interval notation. So probably the easiest way to do this is to make a number line. So you hopefully remember how to do this. I like the number 3. Why? Because that's what I used. Okay, I want to know all of the numbers that are bigger than 3. So I'm going to shade everything over here because everything to the right of 3 is bigger than 3. So remember, this is just a number line in order. So there's like a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Now, what you would have done is make an open circle there. And that's just saying that that point is not included. Okay? So 3 is not included. Why not? Because 3 is not bigger than 3. But 3.00001 is included because it is bigger than 3. Okay, so 3 point, a bajillion zeros, 1. is bigger than 3, so that works. So that's why you have to just shade everything, because there's an infinite number of numbers that are bigger than 3. So up here, the greater than and the less than would have used an open circle. And then the greater than or equal to, less than or equal to, would have used a filled in circle. Okay, and we'll get to that in a second. What we're going to do is change it to brackets. So if it was an open circle, or if it's just greater than, less than, we're going to use parentheses. Okay, but I'm going to call them soft brackets. Outside of math, you can call them parentheses. I call them soft brackets. If it can be equal to, you're going to use hard brackets. Okay, so notice that the or equal to has a little horizontal bar. It kind of like takes the place of the equal sign. Well, these also have the horizontal bars. Okay, so here's what you're going to do. You're going to read this from left to right. You're going to tell me where it starts and where it ends. So as I'm reading this from left to right, where does my answer start? It starts at 3. Okay, where does my answer end? My answer ends somewhere in infinity, or it doesn't end because it goes to infinity. Okay, so now we got to decide the brackets. What kind of a bracket does the 3 get? Well, the 3 has an open circle, so he's going to get a soft bracket. Okay, and infinity, you can never equal infinity. So infinity is a concept, it's not a number. So if you ever are using infinity, either positive infinity or negative infinity, you will use soft brackets, okay, or parentheses. So I'm going to say that it goes all the way out to infinity. So this is an inequality, and this is interval notation, and they mean the same thing, they just look completely different. So let's try one more. What if I say that x is, that's not what I wanted to write, x is less than or equal to negative 7. Okay, so make your number line, which you don't have to make the number line, it just helps you see it. So here's negative 7, because that's the number that I'm interested in. So where do I shade? What numbers are smaller than negative 7? Are they the ones over here? No. Are they the ones over here? Yes. So everything to the left is going to be less than. And then what kind of a circle would I put? I would put a closed point. Okay. And now tell me your answer, reading it from left to right. Where does your answer start? So up here, it went off to positive infinity. Over here, it goes to negative infinity. So I'm at negative infinity. And then where does my answer stop? He stops at negative 7. So I've got my starting point and ending point. Now tell me what the infinities always get. They always get a soft bracket. And now what does negative 7 get? Negative 7 has a filled in circle, so he's going to get a hard bracket. Okay? So that's interval notation, and you can look up interval notation. I'm hoping that was a review. But the last thing that we need to do is look at the difference quotient. So I'm going to write down what it is, and then we will give examples of it in the next video, because I have to keep these to 15 minutes or less. Okay, so your difference quotient is going to be f of x plus h minus f of x all over h. Okay, and what we're going to do is substitute. So remember, I can evaluate, because it used to be f of x, right? So I'm going to trash the x. What am I going to put in its place? X plus h. Okay, minus. Write your original function, and then put it all over h. And this actually dips your toes into calculus. Okay, so you've heard of calculus. This is important for calculus. So if you're taking business calculus next semester, which I don't know if BUA offers that or not, you will learn all about this. Okay, so anyway, that is our intro, and then we'll start doing some examples.